Welcome, science educators and curious learners. I'm Leanne Thiel.
And I'm John Rogers. Today, we're introducing a dynamic hands-on unit using the 5E instructional model. Engage, explore, explain, elaborate, and evaluate. Our subject, graphene, a cutting-edge material, and how it can help address real-world water pollution problems.
In the Engage section, we start strong by sparking curiosity. Students watch a short video titled What Causes Red Tides? This will introduce the problem of harmful algal blooms, that strange, green, scummy water you sometimes see in lakes and oceans. This will lead students to ask questions like, what causes these harmful algal blooms and why do they matter? Afterwards, students sketch what they think these blooms look like, label potential causes, and participate in a gallery walk. It's artistic, interactive, and a natural entry point into real environmental science.
Next is the explore section. In this explore section, this two-part lab, students test heat transfer and water filtration using graphene. In part one, they investigate how graphene thickness affects how fast heat moves along plastic strips. In this lab, students lay out different thicknesses of graphene material and test to determine how the thickness of graphene affects heat transfer. In part two, they compare two columns containing beads, one column with graphene-coated beads and one with uncoated beads. Dyed water passes through those columns, and students compare how effectively each column filters the dye. They gather data, graph results, and ask real scientific questions. It's hands-on, minds-on, and aligned with NGSS standards. Students explore material science through doing.
The third E is the explain. After observing experimentation, students move from what happened to the explain section, why it happened. Through class discussion and guided notes, they reflect on the experiment and some key questions. Which graphene layer worked the best? And why did some filter more effectively than others? We introduce the science behind the core concepts of adsorption, thermal conductivity, and surface area, and link it to real-world science. With the video, visuals, and an exit ticket, this phase helps students explain and own the content they discovered.
In the elaborate section, students use what they've learned and apply it creatively. They're challenged to design and test shade ball prototypes that would be the most effective at reducing water temperature and algae growth. They decide on a coating material, activated charcoal or carbon black, and how many layers to apply onto their shade ball. Over 5 days, they test their shade ball under grow lamps and collect data with tools like a thermometer for water temperature and a Secchi disc for algae clarity.
Next, we will see what each student has learned. To wrap up the lesson, students enter the evaluate phase. Each student will choose from our choice board to present their findings, either as a Shark Tank style pitch, a flyer, a commercial, or a product review. They explain their shade ball prototype, justify their material choices, and use evidence from their experiment to back it all up. A clear rubric will be given to help guide their reflection and communication, and creativity is encouraged. This phase shows students that science doesn't end in the lab. It ends in communicating your findings.
From investigating properties like heat transfer to harmful algal blooms, this lesson challenges students to think critically and engage in meaningful, real-world problem solving.
We want to thank the AEOP for allowing us to work with our research scientist, Dr. Jesse Roberts, this summer and giving us this opportunity to design this lesson. Thank you.